My name is Albara Abu Ida. I'm from Sudan. I'm doing PhD in UTM. My related area or my research area is in information retrieval, specifically in automatic text summarization. In my research, I use the evolutionary algorithm in order to improve the summary quality. In order to improve the summary quality, the outline of the paper and the presentation. Basically, the automatic text summarization started in 1958 by Lon, and the challenge in text summarization is to select the top representative sentences from the document, and then those sentences used to represent the topic of the document. And there are many approaches used to select the best and the important sentences from the document. For example, the feature weighting used, there are group of features used to select the sentences from the document, and other researchers use the graph base in order, for example, they represent each note or each sentence in note, and there is a link between sentence to sentence or note to note, and there is also sentence clustering. In these papers, we use clustering approach in order to achieve the diversity, because in summary, people when need to generate a summary, the summary should be diverse, should not have repeated data. For example, because the summary sometimes is reached to 20% from the document. If the document have 25 sentences, so the total number of sentences should be generated is 5 sentences. Those 5 sentences should be all diverse, not repeated, and include the whole topic or cover the whole topic found on the document. We use the optimization or the evolutionary algorithm in order to optimize those approach. What are the approach? As I said, they are feature weighting, graph based, and sentence clustering, as I said. So here we use the differential evolution algorithm in order to optimize the clustering. So already this means the diversity is also optimized. If I optimize the clustering, so we optimize the diversity. Here, the main concern of the papers, these papers are based on Algolith researchers published paper in 2009, and we try to apply the practical part written or found on the paper, and we found 2 limitations actually. One limitation is the author is used normalized Google distance similarity. This similarity, when we apply it, as I will show later, it has a problem when employed with single document. The other approach or the other limitation, there is some complexity found when he used a genetic mutation, and we will show step by step how this limitation occurs and how to classify them. So in these papers, the content and the contribution of the paper, we enhance the NGD by using alternative similarity measures called Jacquard, and we propose a new modulator used to modulate data or to modulate real data to integer data inside the chromosome. Also, Algolith is used the sentence during in the clusters. He used the centering in order to select the best sentence from the cluster. But there is a problem with this approach, and we replace this approach by using feature-based approach to select the sentences from each cluster. Okay, let us introduce some information about the normalized Google distance and see what the problem. The NGD is principally similarity measures proposed to score semantic similarity between query and document, because it's basically used for computing similarity between large databases. Example, if we search the word or the term horse in Google, I got 47 billion web page, this is the number of retrieved data. Also, we try to find the rider, it retrieved 12 billion web page, and both of them, the relation between both of them, we found 2 billion. At that time, Google indexes 8 billion web page, or 8 million. Okay, how NGD computes the similarity between both those terms? NGD is basically used first, for example, to compute similarity between two sentences. They use first two terms, try to find the similarity between two terms. And this is the exponential function for NGD, where NGD is equal to the maximum, we calculate the log of the maximum number contained in term I, or in this case, we compute the maximum number of web page contained in term I, and maximum number of web page containing term J, and maximum number of web page containing both terms, for example, horse and rider. In the calculation, here we use the semantic, the similarity between both web page, and then extract a score. Here, this is the example, and then we got 0.4, this is the similarity between horse and rider. When we apply the concept of this equation in text summarization, because I'm working in single document summarization. In single document summarization, the problem, I use DUC dataset. The DUC dataset, the length of the document is not, it range between 20, 30, 10, and so. So it is very little. This is cause some variation in the calculation, because the NGD is basically depend on the large number of web page, because this, for example, avoiding to fall into division by 0. But in our cases, it occurs, because when we apply the system and input the document into our system using the NGD similarity, the system report there are two sentences have the same, there are two words, MI and MIJ are equal. In this case, the subtraction for two log are 0. This is cause is lead to division by the 0 is infinity and the 0 also. Here we got number of sentences is equal to the number of the word of the sentences. The total number of sentences minus a number of sentences containing, for example, term I. We got it 3 minus 3 is lead to 0, the division by 0. So in this case, for example, in live databases, normally not easy to occur. As I show, there is a billion number of web page. So we got unexpected similarity results. This means this sentence, this document have 14 sentences, and each sentence to sentence have a good relation with other sentences. And we found that, for example, the cell, this cell, this one, we have this sentence. However, doctors learned that long inactivity did more harm than good. And other sentences said patients got out of shape, developed blood clot, and became demoralized. Both sentences are dissimilar, because after we do the reprocessing step, for example, removing the stop words and do the steaming, both sentences, the bag of words are dissimilar to each other. But the NGD reports that those sentences are in high similarity. So this led us to improve a new methodology to handle the limitation of how to apply NGD or actually this is featured and how we can improve the NGD and to be adaptive in working in single document summarization. But in this paper, we use another similarity is JACAP. Another work we done, we replaced the genetic mutant operator used by the, I believe, the previous work. He used to move the particle from mutation stage into a new generation because he canceled the crossover stage in the differential evolution. And he used the genetic mutant to move the particle from one generation to other generation directly. This is the steps found. And we replace all those steps by only one equation. And we replace mutant operator by only just modulator. We will show. This is the way how the genetic mutation in the previous work work. Maybe I can explain if anybody like it later, because it is highly related to the steps discussed here. So the methodology proposed in these papers are: first, we replace the NGD with Jacquard coefficient. In this paper, Jacquard similarity is used to improve the cluster performance because the NGD gave us some miss or incorrect similarity measure. So that means the clustering is not or inaccurate. So we replace the Jacquard to give us a new or improve the cluster performance, and then compare the result with one obtained by NGD. We will compare those. This is the Jacquard result. For example, the last sentences we compare, it is 0. So there is big difference between both similarity measures. This is DE Jacquard. Another one, as I said, we replace the genetic mutant operators by using only or by proposing only one equation used to modulate the data from real to integer. Why real to integer? Because we need to handle clustering. So we cannot say cluster 0.95, but sequence cluster 1, cluster 2, cluster 3, and so on. So we modulated the data from real to integer. Simply, it's aimed to correlate the generated number of the genome with number of required clusters in this equation and the size of the generated summary. We try to correlate all those parties, and then we got the probability of the one chromosome is by the number here. The DE chromosome M is the upper value because we have value range for the real number. And then value boundary of the DE generated, and the K is the number of cluster required. Here, for example, I discuss. This is a chromosome. This one is a chromosome, and we have 25. 25 means we have 25 sentences in the document. And the chromosome is holding real data. For example, the gene number 1 in the chromosome is 0.3. Then we enter the function to our here we see how many cluster do we need. For example, 5 cluster, and M, it is the upper range, it is 1. So we got 0.2 range for each cluster. That means what? If this gene is holding 0.3, that means this gene will be belong to cluster number 1 because it's range from 0.01 to 0.2. 2 for each gene, 0.2 for each gene. Then the modulation is occurred in this way, and then we replace the values, the real values, into discrete values, and then here we could move each sentence to each cluster. This is the chromosome representation, how we represent the chromosome. For example, sentence 1 will be assigned to cluster number 3, sentence 2 cluster number 1, and so on. In optimization technique, in order to adjust the process of the optimization, we have to assign objective function. Here, the objective function, because we are trying to optimize the clustering, so it should be connected with the clustering process. Here, we try to enhance the similarity between the member of the clusters by the intra-cluster similarity, and try to maximize the dissimilarity between a member of a cluster and other cluster. If we got this solution maximally, this means we are on the right way. Then we compute the objective function. It is a correlation between both intra-cluster and inter-cluster similarity. The DE is need parameter to work, and they were set as found in the literature. The F factor used to adjust the mutation, and the crossover used to increase the diversity of the selected chromosome and the number of the population. Here we use a number of selected features in order, after we do the clustering, we compute a feature or features for each sentences in order to select the top representative sentence from each cluster. The data set is used, the DUC data set, document understanding conference, and the evaluation measurement. This is ROG tool, is a standard for using in evaluating text summarization results. The experimental results. We in automatic text summarization normally compare the system method with human method. So because the DUC is give us two human models. So I compare one human model to other human model and then consider this is as a reference method to compare with, and the rest are system method. We need to see the much closest system method to the human performance. Here, because we have Jakob and we have NGD similarity and we have genetic mutation and we have the new real integral modulator. So we have 4 results in these papers, and the best one is when we use the genetic with the Jakob, and the lowest one when we use the differential with the NGD similarity methods. And the best one is our proposed method to the closest human based on the average score F score, and we compare our result with the benchmark system. Is best system in the DUC and the worst system in the DUC found on that tab. This is structure, and here we have our method is could outperform the human result, and this is the row L. The conclusion, we are employ a previous work and try to improve such limitation found there. For example, the use of the normalized Google distance similarity and how it is unsuitable for using in document summarization because for the small length. And also we propose a new modulator in order to modulate the data from real to integer data in order to be suitable for clustering the sentences. This will happen in the papers, and thank you for your attention.
Thank you very much. Questions?
So your approach is based on the extracting the most important sentences from the document, right?
Sorry?
So your goal is to extract the sentence, right? Not the no. There are two different approaches for implementing summarization, right? One is extraction. The second one is some kind of reorganization of the words to representing the real meaning of the document. Am I right?
Yes.
So your approach is the first one, right?
Yes.
Extracting the most important sentences from the document.
Yes. Because here we are not concerned more in doing NLP, natural language processing, more. We are just, because we are working in extractive-based summarization. In extractive, just matter of selection the best sentences, not going deep into processing the natural language.
Well, I'm an expert on summarization, but somehow you can segment the sentences. One sentence can be divided into several phrases or some clauses.
Yes, there are many challenges in summarization. For example, that the chaining of the sentences, the author should be corrected. There are many challenges, and maybe because, for example, in the abstractive, because abstractive aiming on editing the sentences itself and see how it's connected to each other in order to produce summary that coherence and consistency.
You have sort of clustering. Okay, you cluster some sentences, the text cluster in some groups. Yeah, and if you want to make a summarize, how do you make it?
A cluster.
From your method, you have clustering. You take the sentences, the best one.
Generating the summary.
Yeah.
From each cluster, we compute features. We see the highest sentence with a score of the summation of the features. This means it is the more suitable to represent the topic of the cluster. So we select the top sentences from each cluster and then compose a summary. In other words, a diversity here is achieved.
Okay, but have you tried and have you read what the methods you receive? What the results you receive? It's readable?
Yes, there is many really, yes.
Yeah, because I imagine that there are some, for example, acknowledgement in the paper, and you took the best sentence from acknowledgement and put in the summarize.
Yes, as I said, the problem of the extractive summary, it is only concerned with selecting the sentences. So people in
I think it's
abstractive,
far away from...
it is, for example, this can be considered like a work in progress, because the extractive summary can be also enrolled into another stage for the editing, for example, the abstractive sentence. Here, the stage of the or the concern of the extractive is aiming on identifying the best sentences. Then it can be processed later.
Okay,
It
so
can be-
it is a first stage of
Yes.
the whole process.
Yes.
So you have a long way.
Actually, it is not a method to be a first stage. People in abstractive consider this is a stage, but we are in extractive, consider it is generating a whole summary. Sometimes we compare with the human. Because of that, we compare with the human, and as you see here, the method could outperform in terms of result. In terms of result, could outperform the human performance, the system method. Sometimes the summaries can be coherent, concise, but still,
I think it's the aim itself from the perspective of what's the final useful of the summary. So research people in this characteristic, they actually looking at, okay, if I am a reader of a news, I just want to know what's going on inside this news. So rather than a summary of it. So if you want to read, yeah. So it's
There are some useful.
yeah, it's like a more assistive, not really final result. So I think that's
It could be like online assistance for summarizing the page of the journal or something.
I think because he's focusing.
it is informative summary. It is informative summary. You want to know in highlighting. But for generating more qualified summary, this research area called abstractive summary. Because what they do, they let the computer imitate the human when they summarize. For example, the human is read the book, and then after reading the book, close the book, and then generate a summary. Maybe the term found on the summary, not like the writer is used. Here, different words, different terms, different ideas, different concepts. Here, the abstractive people or the abstractive researchers use to compute how to let the machine generate abstracted summary. This is another challenge and deeply concerned on natural language processing.
Sometimes, because this is very context-related method, and sometimes the text, technical text, scientific text from chemistry or biology, it's really only half-page paper and only equations. And how do you manage it?
Not possible.
Yeah. Okay, but this is the question open. This is not so very special. Yeah, very special area, and but there are some. It is not general. That so it should be.
The data is text data. The data, for example, the medical data. Is it from on text format or in table format?
At most tables.
Text data.
There is also there is a research actually in summarizing tables. Tables and figures. It's very recent actually. Defining the transaction of information system. ACM transaction information. We are looking for information and summarizing the tables.
But the problem is very interesting. Thank you very much.